Hello. Thank you for waiting, everyone. How many people have been to one of our meetups before? Okay, most of you know this spiel, but what's going to happen is we're going to wait for questions to the end. If you do ask a question, be prepared to fill out a form which Christina will hand you. Please don't say anything that you don't want broadcast on the web because we're live streaming tonight. We've got a great lineup, I think. Jack Herrington from Lithium Technologies is going to come talk about doing visualizations in Angular apps by mixing D3 with Angular. And then Julie, Ralph, back in the back, is going to talk about our new end-to-end testing tool, Protractor. We've got a couple of the Angular team members along the back there, Mishko, Vojta, Igor, and a mild celebrity, John Lindquist, is also here, author of egghead.io. No, he's fantastic. But his day job is he works at JetBrains on fantastic editors. Anyway, without further ado, I'd like to bring Jack up. Give him a hand. We'll learn about D3 with Angular.
All right, can everybody hear me? All right, we'll try and get this thing oriented right. Okay, before I begin, I want to say thank you for having me. On your screen is a URL for the GitHub. So if you want to just start having a look at that, it's free. You can play with it all you want and walk through it. My name is Jack Herrington. I work at Lithium Technologies. I'm a principal software engineer there. I'm not on Angular or on D3, so I'm just an engineer like you guys. And so I'm basically got a lot of experience working on these two technologies, and I'm kind of here to impart to you what I've seen in terms of just how to make it work. Okay, so I'd like to get a kind of show of hands on a couple of things. Who has done Angular directives? Excellent. Written Angular directives. Fantastic. All right. And if, by the way, so if you haven't, the egghead.io stuff on directives in Angular, fantastic. So you should watch that set of videos, and they're free and they're great. Okay, how about D3? Anybody written D3? Okay, and one last one, worked with the scalable vector graphics standard. Done images, that sort of thing with scalable vector graphics. Okay, cool. All right. So that gives me a sense of who I'm playing to in the audience here. So data visualization. I mean, I'm used to walking around, so I guess I have to stay in one spot for this. Data visualization. So why is this important? It's important because nowadays, we're doing MapReduce, we're doing Elixir, we're crunching through this ton of data that we have on user behaviors and things like that, and we're trying to gather some sort of insight out of that, right? And at the end of that, we need to present that to somebody. We need to present those findings to people. So we have to visualize that somehow. Now, when you look into visualization, the guy that you're going to find kind of at the crux of all of it is this guy, Edward Tufte. So Edward Tufte has been doing visualizations research and writing and lecturing since 1975. You think, what's the guy have to do from 1975? That's going to be back on graph paper and all that sort of stuff, right? But there are fundamentals to actually how you present data the right way and have respect for your viewer and how you let the numbers speak for themselves. And that's really what Edward brings to the table. He's got 4 great books on it. He gives fantastic lectures. Your company will probably expense you to go see it, so you should definitely see him. And one of the things that he talks a lot about is, right now, because he keeps up with technology, Mike Bostock and D3. So D3, so what's, everybody talks about it, it's a big thing. The whole concept is that we're gonna go and take data that we've gone and developed in whatever arrays or something like that, and we're gonna hook them into nodes that we're gonna build out of SVG. So why SVG? So there's a couple of different ways that you can put graphics up on a screen, right? You can put them up through PNGs or GIFs or JPEGs that you generate on the server. You can create a canvas tag and do, kind of point-by-point bitmap creation of your graphs. Great. Or you can use SVG. So SVG is scalable vector graphics. You basically say, I want an image of this size. It's going to have this viewport. And then there are subtags that you can put in there that have things like lines and rectangles and circles and ellipses and arcs and paths and all this kind of stuff. And you can use that to build graphics. and all of the and make it dynamic. And the beauty of SVG is that it is scalable, right? The computer then or the renderer in the browser along with the graphics card renders out to whatever your display level is. In some cases it's going to be Retina display, in some cases it's going to be 72 dpi, and if it's on your kid's broken Nintendo DS, it's going to be like 2 pixels and whatever. And it's, it'll render properly within that setup. So let's go. This is kind of an interactive sort of thing. Edward Tufte were here, he'd probably hate me for, because a gauge is a terrifically terrible use of data density in space. There's actually only 3 variables here, maybe 4. So there's the minimum, the maximum, and the current value, so 0, 121, and then there's the name. And for that, you take up this amount of screen real estate. But, I guess if you're an executive, you're like, oh, I need my dashboard. I mean, I need my gauges, because it's got to be like a Ferrari. We spent all this money on it or whatever. So the coolness about this particular one is D3's, the examples, again, it's kind of like, it's like I want to say, it's not Slashdot, the code site that we all go to every day. Anyway, Stack Overflow, that's the one, right? It's kind of like Stack Overflow. You get the code, you munge on it, and then you make it work, and then you're good. And then the code is generally kind of in the page, is one spot. There's even the data's in the page, and it's just not well organized. This one particular thing that he's done is actually really nice. It's actually developed as a JavaScript class. It's got methods on it where you can go and update the value and things like that. So it makes a very easy component to integrate into D3 because it is structured that way. All right, so that's cool. So here's how we're going to get D3 and Angular to play together. And I'm going to go through this super slow steps. We're going to first start by looking at the D3 code itself. Then we're going to set up a very simple Angular app. You guys are all going to be very familiar with how that's done. We're going to build a directive. Slightly less of you are going to be familiar with how that's done, but again, keep it simple. So you're going to learn, not as well as you would with egghead.io, but I think reasonably well about directives. Then we're going to make it dynamic, but we're going to use jQuery. So if you're familiar with jQuery, this should be fairly simple. And then we're going to bring in the D3 stuff. And finally, we're going to make it bidirectional by adding a click handler on the D3 object so that you can actually make it kind of interactive. Okay, so let's look at some code. This just looks terrible. This is like from 1985. We have a couple of spans in here with IDs. Great. Okay, so let's look at Mike Bosock's gauge stuff. Again, it's done in a classically JavaScript object-oriented style. We're defining a function. It's got a configure on it. It's got render, and it's finally got a set value at the bottom, somewhere in there. But most importantly, I think, as I go along here, it's interesting to note how in this case, D3 does what it does, right? So this is the way D3 creates nodes in an SVG element. You have a body element, you're going to append, I think that in this case is the SVG element, and then you're going to go and add lots of attributes to it, you're going to fill it, everything has these styles, and so on and so forth. This is how D3 does it. When you think about how Angular does it, Angular is going to have a template with like little, mustache stuff in it and all that kind of thing. It's just two different ways of thinking about it. And the nice thing about D3 in this case is that each one of these could actually be a function, right? So it says that in the case of this, instead of just taking this value, call this function and give it the current data, and then it comes back. So for example, if you are creating circles for each one of your data elements, you might have a radius on it, and then you have the function which then tells it which radius to use, that sort of thing. It's very clean. It's just a different way of thinking about it. And if you're into functional programming, which is kind of the new thing, like with Scala and Elixir and all that sort of stuff, this is very functional. There's a great book, by the way, on functional JavaScript, which is kind of along these lines. And it's got that nice cascading style as well. Okay, so enough of that. Our page logic, which is just going to go and instantiate a couple of these guys, is just going to do things like set up and config with the size and the min and the max and the whatnot. And then it's going to create a new one. This should all be fairly simple. because we're using IDs, we're going to go and select one by its name and so on and so forth. And then, you know, there's some creator and an updater. Let's go take a look at how this is going to look. So we'll, and again, if you have downloaded the code, you can play along in the home game. So I'll zoom in. That's nice. And after, what is it, 5 seconds or something like that, it'll start to update. Now, oh, by the way, so I mean, this is really where SVG shines. Notice like the middle of that, of the pointer. I don't even know what that is on a gauge, the dial hand or whatever it is. As it went over the U, it was just a little bit opaque, like a nice little opacity in the middle. Like notice like between the O and the R. Just, so nice. And imagine trying to do that in like PNG and do it dynamically. And we're not going back to the server for this. This is all on the client. Just really sweet. Okay. So we want to get that. We want to get that into our Angular app. So let's go build out a simple Angular app. Up at the top, you're going to have your ng app. This should all be pretty familiar to most people. You have a controller, happily named my controller. And there's going to be some values in a hash for, I think it's petrol, oil, and something starting with C. And we're going to have a randomize button that's going to randomize it. We'll go over here and look at the code. Woohoo! All right. And we're just going to set up the values, and then the randomize callback just sets some random stuff, and there you go. Nothing too exciting about that. So let's take a look at how that works. We'll boost that up a little bit and randomize it. We get some great super floating point numbers with all kinds of decimal precision. What we really want to do is we want to go and take one of these gauges and turn them into a directive so we can have on the page, you know, a gauge. Let's be able to say gauge like that, right? Give it a min, give it a max, give it a value, give it a label. Oh, let's see. So, petrol, oil, and coolant. That's kind of cool. I'm assuming that if any one of those goes negative, you're probably going to have a pretty bad day. I would think. All right, we're going to bring in Angular, and we're going to bring in the custom gauges code. It's just the JavaScript for the page. And the app is going to be called component. We had to name the app now because we're going to assign, we're going to add directives to it, so we actually have to have an app object at this point. And then again, my controller, and again, back to the randomized stuff. So let's go take a look at this. This is now getting into building out a directive. So my controller remains exactly the same. Now we're going to build out the components app. We're going to add a directive for gauge. That's going to be an element directive. There's a couple of different flavors of this. You can put on an attribute. You can do it. I like element. It reads well to me. We're going to say replace that gauge element with whatever is in this template. So it's going to become a div. And then we're going to give it some attributes. An at, I guess, takes the value. And then this is going to be a bidirectional connection between the min, the max, and the value. So if I set the value in the controller, it's going to automatically update inside the gauge by the magic that is Angular and the reason that we all love it so. Let's have a look at that. Oh, and I like how it's zoomed. That's nice. Thank you, Chrome. Okay, so we have the min, we have the max, and we have and the label, min, value, max. Label, min, value, max. That kind of makes good amount of sense. Cool. So now we trust that we have this gauge element, and we trust that it can go and bidirectionally get the value into it and all that kind of fun stuff. So, okay. Where are we on our list of things to do? Yes, we're about that far. Problem is, you get to this, oh, right? So you had all this great, oh, I love D3, yes! Now I want to get into a system that actually thinks that it owns the entire DOM. But wait a second, D3 thinks it owns the entire DOM, and they both want to go and add stuff to it, right? And we got this really cool D3 stuff where it's got the functional syntax, and I still want to use that. And we've got the Angular stuff. It's got the ng repeat. And these two kind of do the same sort of thing. They just do it in different sort of ways. So how do you get these two to actually talk nicely together? So that's where you start getting to the link method. This is a cute little thing. So the reason is I'm even up here, and I'm sorry to say this, is that the directive documentation is so bad on Angular that you kind of need a thing like this to go and tell you that there's exactly one special method that you really need to know, which is link. So instead of having a template, this is almost exactly the same code as it was before, but you have this now link function that after the object has been created, or after the directive has been created, it's got a scope, and that scope's here. So we have an isolate scope. It's such a great name for something, isolate scope. It sounds so cool, you know, isolate scope. And then you have your element, and it's really all you need. I mean, there's some attributes, sure, okay, fine. Okay, so then we're gonna, I don't know, you guys are probably familiar with some jQuery stuff. There was a thing before Angular, it's called jQuery. And so I'm gonna go and append this div to the document, and then when I watch and the value changes, I'm going to empty that and then append it again, because I'm messy that way. And let's take a look. Step 4. Cool. And yes, that actually does work, right? So I'm now generating stuff, and it's connecting to Angular, but it's not being done by Angular's templating mechanism, which is kind of the secret sauce here. So when you think about anything, JQ-plot, high charts, I think you were talking about high charts. There's a bunch of different things out there for this. Anything that's going to go and build nodes that Angular doesn't know about, this is how you're going to want to do it. You're going to go and get your element out here, and you're going to want to start hacking on that element, and you're going to connect it to the scope using this scope right here. Okay. So we're getting close, right? Same thing as before. Now we want to go and bring in the D3. So we've had to go and bring in the gauge code from Mr. Bostock. And this is looking awfully familiar. This is like what his original code was doing. And we're going to redraw, but in this case, we're going to, the only changes here are that we're going to bring in stuff from the scope, scope min, scope max, from the attributes, the label, and then we're going to set that to the scope value. And then when the scope value changes, we're going to redraw the gauge. Step 5. Oh, wow, that's big. Okay, there we go. Nice. There you go. So here's our Angular app controlling D3. Thank you. And if you go on Stack Overflow, I remembered it this time, you will find some patterns. I found them initially that talk about using create, and I think there's one other method, or create and compile as callbacks. In fact, one in particular, there's basically a singleton element that it creates and then attaches the directive to. And so if you were to create 3 gauges, you get 1, and it would be the last one. And it was terrible. So, but you know, so you can't trust everything you see on Stack Overflow. You can trust everything you get from me, though. I think. Okay. Now we want to actually make this dynamic, right? We don't want to go and only have gauges that display stuff. We want to get them so that they're interactive. So the last thing to do is to actually hack on Mr. Bostock's code a little bit to go and add quite a bit of math that I needed to do some remedial stuff in. Thank you, Khan Academy. So this is basically converting XY coordinates to degrees. Actually, it's more Stack Overflow than Khan Academy. And then there's a click handler on click here, which you first get the degrees back from that nice handy self degrees function, and then you pass it back to the click method that's been passed in on the config. So let's go look over here. So now the first thing we're going to do is add to the config this click handler. It's going to get back the value. The gauge is going to set itself, and then it's going to call scope digest to let Angular know that there's been a change. From what I hear, coming in 1.2 with the ES6 stuff, you don't actually have to do this anymore. There's going to be event.observe stuff, but for the moment, we need to go and let good old Angular know that we've actually done something so that it actually can update. And then we're going to call back the click handler, and then the click handler in this case is basically just going to come over here, just going to call a set function locally. Oh, hello. And what does that do? That just dumps out to the log, so we can go and see that we're kind of round tripping a little bit. And interestingly, the way that you specify like a method callback like that is using ampersand. I guess that's kind of a harkening back to your old C and C++ days. I like it. Okay, and we'll take a look at that. Step index 6. And there you go. So click. Voila, an interactive graph. Nice, huh? Sweet. Oh, thank you again. I appreciate that. The crowd last night was a little bit hush, but that's okay. That's cool. You guys are great. Because these are kind of I did want to show some really cool stuff. So there's 2 more little demos, but I do want to, so there's some things I want to reiterate, right? So one, it's important to have for each directive, it's important to actually specify the scope so that you have one. And then you want to get the element and send it to D3 as I showed you through that link method. As I said before, the D3 stuff that you're going to get from Mike Bostock is not always as well architected as this gauge. So you're going to want to go and take what he's given you and wrap it in a class. So as I said, you want to use scope digest. So I was asked last night, hey, how to do this maintainably. So I figured I'd use OmniGraffle, my favorite graphing app, whatever it is, image app, and make a nice little kind of workable thing here and show you that. So here's kind of how you want to design it, right? At least this is how I've seen it work well. At the top, you've got your Angular app. It's going to talk to an Angular directive, which you've seen through the gauge stuff. That's going to call the wrapper class, which in this case is Mike Bostock's gauge class, but usually doesn't exist, so you'd need to create it. And then within that, it's going to call that D3 code. And the nice thing is, in this case, you're basically kind of getting 2 birds with 1 stone. You're getting a nice Angular connector layer there, but you're also getting an encapsulated class so that your vanilla JavaScript, if unfortunately you're not using Angular, which I can't imagine you wouldn't be, you would still have access to your really cool data visualization. So it's sexy. I did want to show something that was actually really cool. And it's Hexbin. It's also in there. I thought this was really neat. I like this. This is, kind of, I'm a big fan of board games, especially like old Avalon Hill stuff. So Hex has always made me happy. So here's an HTML5 slider control up here, and through the magic of Angular, it's setting this radius, I guess, in the D3 visualization. I just think it's neat. So there you go, and you can go and play around with that code. And then there's one last thing I want to do because, oh wait, well, let's go. Sorry, one more thing. I'll go back to that slide. I wanted to show you in Palmer. So how many people are familiar with Palmer? Okay, so let's make you even more familiar with Palmer because I'm really digging on Palmer. It's not out yet, but it's super neat, and I like it. And it's in there. It's not so easy to actually install and work with, but it's cool. Okay, so we're going to do the same thing as we did before with the gauges. Here's a nice little booter page. It's got all kinds of stuff in it to make it all friendly with all the different browsers and whatnot. But basically, and it's Bootstrap, which is even better. We're going to have a TK app, which is a custom control or custom element. And then for each custom element, you have basically a template and then a corresponding, well, to use Microsoft terms, like a code behind. That is, yeah. Okay, well, whatever, it's code behind the code. So, yeah, you give me a better name. You say basically, this is the code that's going to drive this particular template, right? It's very contained. I like that. And then with each one of these gauges, this is going to be the code that runs the gauge, right? So you give it a template, that's going to have a span. The attributes are nicely attached to the basic hash, which I think is nice. It's very clean. when the value changes, you get this value changed method. I know that's a little odd because it's a little ambiguous, but if, it, for example, min changed, it would be min changed. If max changed, it would be max changed. Label changed would be label changed. And then there's a created one that's called when you created. So again, much the similar flow, and I can show you this working over here. And so this is this version. To get this to run, you're going to need to do npm and yeoman and all that kind of fun stuff. It's just a little bit more difficult than Angular. Okay, so let's do one last slide and then we'll wrap up. Okay, so this is just for you guys. These are things that sit on top of D3, like, for example, my Angular tree map that you can get on Lithium Tech, which is nice. Consumable tree maps. There is a set of Angular 3 directives, D3 directives that just make it a little bit easier to write D3. There's a graphing library called Dangle, unfortunately dangle.js, but it's cool. One thing that people really like is D3 chart. It's just a bunch of kind of standard line charts, bar charts, that sort of stuff. In all honesty, I know D3 is very sexy and everybody wants to use it, but really, it's only for the times when you have something that's a super custom visualization. If you want to just do a standard bar chart or something like that, you're probably far better off using like, you know, your the charts or the JQ plots, high charts, right, that sort of stuff. But I put these on here for you to enjoy. And as we said, Q&A is after the next session, but I certainly appreciate your time.
Great, thanks, Jack. Welcome Julie up to the stage. She's getting her laptop ready, and she'll be with us in a moment to take us through our new end-to-end test tool.
I made a configuration change. What happened was previously when we switched out of full screen mode, we lost completely the signal that's coming through.
So this is what I'm
I
going to be
want to
doing.
try to just simulate that. I'm going to go check that right now. And
Okay.
This is how you're going to be changing.
Yeah, I'll just do that a bit. All right. No problem. It is plugged in.
No.
Oh, not there.
Okay.
Who did that?
Okay, looks like we got everything worked out. So if everybody could start to simmer down. Hey guys. So I'm an SCT at Google, software engineer and test up in the Seattle office, and been working with the Angular team on some of the end-to-end testing stuff. So today I'm going to talk about Protractor, which is a couple months to for Angular. Who's written an Angular application? Who's written a unit of their Angular? How many people have written an end-to-end framework? Okay, cool. All right, a couple talking about why we do end-to-end testing. For me, end-to-end testing, like all testing, is about confidence in your code and confidence in, is this ready to release? Is this ready to push out a new version? Have I broken everything? And end-to-end testing is by no means a replacement for a really good suite of unit tests. Unit tests are great for testing lots of edge cases and individual pieces of your controller or directive or service. End-to-end testing is for catching the integration between your backend and your front end, between your different services, for testing what happens when you're nationalized or minified or compiled, and finding errors in that. So that's the value of end-to-end testing, and I hope that people will move towards that. I do think that there is a time for end-to-end testing, and that's probably not when you're first prototyping something. But as soon as you need confidence in your release, it's a really great suite to have. So why Protractor? Many of you have probably used the old Angular scenario runner, and that's great, but it's kind of aging and in maintenance mode and lacking some features for end-to-end tests that we like to have. So I decided to write a new test runner that's based on top of WebDriver is open source code. I'll talk about it a little bit more in detail. And WebDriver is all about trying to simulate how a user would interact with your page. And this lets you do native event firing, which is not something that the old scenario runner could do with its iframed approach to loading up your application. It also required some sort of framework to serve your test code and serve your application in the same area, so it's a little bit complicated because of that. Why not just WebDriver? Well, if your application is an Angular application, it has a lot of great structure that we can leverage. Dependency and injection system through which we know all of the modules are loaded. It's got modules like HTTP and timeout that are handling all of your asynchronous requests. And we know a lot about what your template's going to look like because you're going to have bindings and you're going to have input which is attached to modules. And all of these things can be used by your end-to-end test runner to do a little bit better than just black box testing. To do black box testing, but we know it's an Angular app, so we can be a little bit smart. Okay, so as I mentioned, at its core, Angular is a wrapper around WebDriver. So I should probably explain what WebDriver actually is. WebDriver, it starts with a Selenium server. Quick programming note, Selenium and WebDriver projects merged at some point in history. Same thing. Selenium, WebDriver, whatever I say, means the same thing. The standalone server is just a binary which controls browsers, as a user would control browsers. So it talks to a browser that has a little browser driver called like Chrome driver, Firefox driver, etc., Android driver, and it communicates with that over the WebDriver wire protocol. The wire protocol is a series of commands which are meant to emulate user actions, like going to a page, clicking on an element, seeing what the text of an element looks like, finding an element, etc. And then this browser, depending on how the driver has implemented it, tries to make those events as natively as much as a user would as possible. And that's a browser, so it can connect to whatever the internet can connect to. This could be your single application instance running on localhost. It could be a QA instance that you have somewhere. It could be your production application. You might want to do some sort of production monitoring or something with WebDriver. And on the other end here, we have your test code, which can be written in anything that WebDriver has bindings written for. So since we're all using Angular, we're probably pretty comfortable with JavaScript. So we're going to write the test code in WebDriver.js, which is JS bindings for Node.js. And WebDriver is going to Protractor is going to wrap around that and help us out. And your application is going to be an Angular application. So what is Protractor adding for you here? First of all, there's a command line executable, which takes a configuration file that tells your test how it's going to connect to that Selenium server, where your application is running, what type of browsers you want to test on, and a couple of other just configuration attributes. And then inside your test code, you'll have access to an instance of the Protractor class, which has been set up with this configuration file. And that'll wrap around WebDriver, so anything you can do with WebDriver.js, you can do with Protractor. That'll connect to the Selenium standalone server and talk to your code. All right, before I get much further, let's take a look at what this actually looks like. So I've got my Selenium server running here and outputting lots of nice log junk. I have a server running on localhost. And this is my supercalculator application that we're going to be doing some tests with. It has features of slowness. And it has a history of what's been done that gets written down here. This is obviously an Angular application, so this is a table with ngRepeat. These are their inputs. You can take a quick look at the template here and see that you got this first input, an input button which does the addition, and then the latest value is output. And then we've also got the table down here, which has the expression result. Actually run some tests. So as I said, we've got the command line. We run the configuration file. And this pops up a new instance of the browser and runs everything. I'm not doing anything. No hands. And outputs the results to the console. This is using the Jasmine framework and reporters that are probably familiar if you've used Jasmine and Karma and done Angular unit testing. All right, quick note before I dive into too much more code. In all of this, WebDriver is going to base the WebDriver namespace, and driver is a particular instance of the WebDriver class. And similarly, Protractor refers to the Protractor namespace, and Ptor is going to refer to an instance of the Protractor class. So this is what a WebDriver looks like, and since Protractor for it, it's good to understand what's going on before you introduce any of Protractor's niceness. It's Node, so we've grabbed WebDriver namespace with our require function, and then sets up WebDriver by building it with the Chrome capabilities. This could also be Firefox or whatever browser you wanted to test with. Then once you've got that driver instance, the methods on it correspond to actions that are taken over the WebDriver wire protocol. So get a website, find an element, send some data to that element, send keys, basically types as the user would, find another element and click it. As you can tell, this is testing google.com, finding the query box and searching for WebDriver. The way that is with element locators, and these can be by name, by element ID, by CSS, XPath, tag name, etc. This name for use. And then it's important to note that all of these methods return promises. So once you get the title, you can resolve the promise to the actual string value of the title. And WebDriver by itself doesn't come with any sort of testing or assertion framework, so I'm just alerting on a failure right now. So wait a second, if everything is returning promises, how come this isn't just a giant chained, nested, terrible promise fulfiller? Well, WebDriver keeps something called the control flow. And every time you call a method that's going to be sent over the WebDriver wire protocol, it just adds that to the control flow. So at the end of this test, nothing has actually happened on the browser. On the next tick of the asynchronous functions, the control flow will start to empty from the front. This is really important to remember when trying to debug WebDriver tests and Protractor tests. So I will mention this again, but everything goes on the control flow, then everything's popped off of the control flow. All right, so what's Protractor actually adding here? Here's a simple Protractor test for that calculator, which I showed before. that it can add. The first thing you'll notice is that there's a framework here. This is the Jasmine testing framework. You can also use Protractor with other frameworks, but you're going to have a little bit more setup of your own to do. And this is actually a version of Jasmine which has been kind of patched for Protractor. First of all, it's patched so that it runs in Node.js instead of just in the browser. And then it's also patched so that it can run these asynchronous functions without having a runs and wait for blocks, or without having to call done at the end when everything is settled down. There is a Protractor namespace which has been exposed globally, and you can grab an instance from that which has been configured with that configuration file that you passed into Protractor command line. The expect statement from Jasmine has also been patched so that it understands promises without having to resolve them first and put in a nested expect statement. So here you can see these two are absolutely equivalent, and it's still fine to use the promise. But if you want to write more concise test code, you can use expect on a promise, and it resolves as you would expect. One of the best things about this test is something that's not there, which is any sleeps or wait statements. A lot of WebDriver tests suffer from race conditions because they have to wait for some XHR request to return, or they, try to run something before something is rendered. And Protractor can be really smart about this because it knows that your Angular code has to finish before it should try to perform any action. So it waits for any HTTP requests or any timeouts to finish before it performs any action. And this helps reduce test flakiness and cleans up your tests a lot because you don't have wait or sleep statements anywhere in your code. A quick reminder, as I promised, that this is still using the control flow. So if we put a debug statement at the end of this test, nothing will have happened. Everything runs on the next asynchronous tick. Another thing that Protractor is adding here is custom element locators. So instead of finding elements by CSS or XPath, or artificially adding IDs to your application just for your testing code, you can grab by things that you know are going to be there because it's Angular. You have an ng model for your inputs, and you have bindings with your little mustache. So here's a couple of locator strategies that Protractor adds. For that great mustache notation, you have bindings, which also searches by partial match, so you don't have to perfectly include any filters or anything that you've had on your bindings. You can grab it by input, and you can also grab repeated elements by row and column, and by both row and column if you want to get at a particular cell. Okay, so let's actually go and dive a little bit more in depth into this code now that we've started. So let's write a new test to check out what happens when we use negative numbers. So this is Jasmine, so we'll give it some sort of descriptive name. Should add negative. And then we need to element elements that we want. So as you'll recall, there's these two input boxes. And if we go and look into our template, those are model first and model second. So we'll assign those to variables, the first number, and we'll find the element, and then we give it the element locator. And that was input and first. And then we'll do the same thing for the second. So second number. And then just to switch it up, the go button is actually with an ID. So go button. And we'll type all that again. One code is make yourself a nice DSL, which will capture all of these elements that you found. This is a technique called page objects. And that basically says put all of my element locators in one reusable location. Vector typed dot by dot etc. 5 million times. All right, there's the go button. And then we'll do our actual test. So send some keys. Let's do -9. And then the second. Send it. And then we'll have an expectation. And that result was output as a binding, the latest result, and we'll grab the text from that element. And we expect that to equal 1, because we all passed first grade. All right, so we save that, and let's actually run it. I'm going to just override the spec file that we're using here. This is spec2.js. And we're going to get an error for some fun debugging. Can't find module. Should probably be specs. And there might be a parentheses problem too that we'll find later, as someone has pointed out. All right, we run it, and we do see a failure because I have some sort of parentheses termination, line 18 it was called. Oh, no, that's good. We don't want this one here. So inside the expect statement, we have that. This is why you don't do demos. But I'm also showing you how to debug here. An expected token, and we can see that that is run. Well, I don't want to spend too much time trying to debug something that's not going to happen here. This code is all online, so you can grab it on GitHub whenever you want to and see the proper versions of everything running nicely.
I think the parentheses expect is not closed. Yeah, one more at the end.
Parentheses.
Right after the 2 equals. The guy was right. Around expect.
All right, we got the parentheses around expect? Yes? That looks good? That's the one around find element? That's the little get text call? Should we give it a shot one more time? No! No method. Oh, you know what I've done? I've used the namespace here. After I put in that, like, be careful. I'm using the instance of Protractor, as I should have been doing from the start. And the locators are all on the namespace. So let's give that one more shot. I keep lying. Yep, parentheses. And one less here. Pair programming with a room of people. Oh, this is actually, okay. This is something that we want to find. So, couldn't find an element. WebDriver throws an error when it can't find something that you've searched for. So I'm looking for something by ID, go button here. And there's no capital here. So let's fix that. And that's a very useful error to know what to look for. And now everything runs, everything waits without wait statements, and passes. All right, let's look at a slightly simpler error. What if we just have the wrong number here? So we'll run that. We'll wait for our slow calculator one more time. And here we can see that our error message is, as expected, problems. So how would you debug this? You can go in, and before that expect statement, that you can use Protractor's debug function. So we'll call debugger here. If we just put in a debugger statement, nothing would have happened because none of the control flow actions have run yet. And now instead of running Protractor plain, we're just going to put in debug. And this will use the node debugger. So continue, go ahead and run that code. It'll put in the first ones, and then it'll pause once those actions have executed where we had that debug statement. And leave the browser open so you can actually go in and see what's up and see, oh my gosh, it's 1. 1 isn't 6. What have I done? All right, let's quit out of that. So talked about the runner and how you can override values from the runner. And there's examples of configuration files on GitHub as well. So what did we do? We looked over Protractor's features of custom Angular element selectors. grabbing things by input, binding, and repeater so we don't have to make our test code messy with IDs. Looked at the integration with Jasmine that it gives you with seamless asynchronous tests and expectations which automatically understand promises. And looked at the automatic synchronization which lets us avoid wait statements and sleeps. There's a couple of other features which I don't really have time to talk about tonight, such as module overriding, which lets you keep any expensive modules in your actual application and override them from the test code. So for example, if you had a module which did an email service and you wanted to test against your QA application without actually sending any emails, from your test code, you can override that module. And before the page even loads, you'll have removed that service. You can also evaluate statements in the scope of an element if you want to get a little bit more insight from your end-to-end test into what's happening in your code. I'm currently working on a 1.0 stable release of Protractor, which should be coming down the pipeline soon. And a couple of other things after that. An interactive mode for playing with finding element selectors, which is often one of the most painful parts of writing WebDriver tests, is running your entire test suite to get that one error that it couldn't find an element. So an interactive mode, which would give you really quick feedback for any URL. Also tired of typing protractor 50 times a day, so exploring some new syntax which might look a little bit more like what you would get in the Chrome DevTools or with jQuery, but with special notation for Angular features. So this is still kind of floating around in ID land. And then also have team members working on a Java port for those with existing WebDriver suites written in Java. All right, my repository is here. All of the code from this demo is also on GitHub. I'll invite Jack back up.
All right, so nice job. I will run the mic out to whoever wants. If you could make a line out in the aisle.
Is it true that Ashwin gets a T-shirt?
I don't know, Christine, is that true tonight?
It's true.
Yes.
Oh.
It's still true. And we'll trade T-shirts for filling in the form.
They gotta be good questions, though.
Oh, no.
Yes.
Good question for Protector. We've been using Karma, and I really to see what Protractor brings over Karma, because Karma was integrated with Jasmine. It understood expectations, and the DSL language seems like Protractor. So can you elaborate on?
The advantage comes from the fact that it's being run. So you get real, instead of relying on that's hosting your application. Take screenshots really easy with a WebDriver farm. You can get native event firing. End-to-end testing is going, and so it's
and sort of toying with so what are the trade-offs that you've observed?
You know, I was given nature over the template stuff. Yeah, some of the stuff coming out in one diligently
test. Google take a response to
to say, well, what does that human readable sentence actually translate into for your end-to-end test. Exploring an adapter between Protractor and Cucumber is definitely on my to-do list, and as well as exploring easier syntaxes for grabbing elements.
So yeah, actually carrying along the same lines, it'd be really nice to have something that's like a screen recorder where you can go and you click through these different things, and it's generating what you do, what the Protractor code, and then you can go and tweak it after that point. But does the generation at first, you don't have to save a lot of time.
Yeah, yeah. And
You talk about configuration file. So what kind of configuration file we are looking for here?
yeah, let me show you a quick demo. This is the super stripped down configuration file that I used for these tests. It says where's Selenium running, which, as I've shown here, I can start up my Selenium server again, but that's just a binary. What spec files to run, so and what browser you want to start.
What is this specs.js?
Spec.js is just the test file.
Okay, the test file.
That shows everything. Then there's a lot of other things you can add, like if you want to run something before all of your other tests run. So some sort of global setup that might be logging in to your application or setting up custom shortcuts. You could do that from the configuration as well. And also how you want to output your results. So if you want to get this into a XML format so that it can automated build, you would do that from the configuration file as well.
How we handle this AJAX calls over here?
I'm sorry?
AJAX calls, how we'll handle in this framework, so if any AJAX call, asynchronous calls we have.
So I think you might be asking if you're doing like a global on prepare. That's run basically the same way as a test specification would be. So that's run asynchronously through WebDriver, and it waits for any actions to return before continuing.
Hi, earlier you mentioned that you hooked into Angular somehow so that when you did you got around the problem, the sleep or the wait. I was curious if you can go into a little more detail on that, because I've seen similar problems when working with Cucumber and WebDriver. I was wondering how you hooked into Angular to know when it was done.
Yeah, sure. Angular actually has a really great feature in that it keeps track of any timeouts or HTTP requests that are pending. And when it's done with all those, you can hook in and ask for a callback to be called. So Protractor does that before any action, basically.
Do you know off the top of your head what that callback was
I believe
called?
it is notify on complete or notify when no pending outstanding requests.
Okay.
Something like that.
Okay.
Notify is definitely in there.
Okay, thank you.
Hey, so I had a similar question as the last guy. I'm pretty new to testing, and I was wondering if you could talk to testing between different types of browsers, specifically in the case where I'm actually using a jQuery call to do a little bit of animation. And what I found was between the Angular codes on change and then when the jQuery finished rendering, there's a little bit of a race condition between where it rendered fine in Chrome, go Chrome, and then Firefox and Safari just straight up did not process the fact that this was happening before the browser threw up.
Mm-hmm.
So I was wondering if you could talk about how you handle actions or otherwise things that are still hanging out in Angular.
Yeah, so unfortunately, if you're doing something with jQuery, Protractor wouldn't know about it because Angular wouldn't know about it unless you've hooked it in somehow. So the best that you would do would probably be to catch that problem by testing on different browsers, which I think is one of the advantages of end-to-end testing with WebDriver is that it's really easy to switch to a different browser just with this configuration file. You'd make that Firefox and it runs the same tests. And because the protocol is the same set of functions, your test will mean the same thing. It might not work because the application might not work. But.
Okay, cool. Thank you for kind of explaining that race condition.
All right, hi. So if I'm using Protractor and I want to mock out an external service, like someone else's API, for instance, does that use Angular's dependency injection system, or how does that work?
Yeah, it does. So what it actually does is before Angular does all of its module reconciling when it loads up, Protractor puts in a little marker that says, hey, wait, until I've done everything I want to do. And then it calls overrides for any modules. And then it tells Angular, okay, I'm done. You can continue loading up your dependency injection system. And there's examples of that on the GitHub page in the module override tests.
All right, thank you.
For Protractor, you showed an example where you just wrote the test case and that like statically, and then you ran it. Is there a way to like use Grease Monkey to run Protractor like while the page is already created?
So I'm not actually familiar with Grease Monkey.
Grease Monkey allows you to inject JavaScript onto a page that's been rendered.
You So this might be kind of similar to the question of do you want to like run on save or like run your tests like over and over again, which sometimes isn't true for end-to-end tests because you might be setting up something kind of complicated that'll take a little while longer and want to tear down. So it's not really optimized for immediate running. This is sort of more optimized for running, once you've finished a suite, you want to do that. That's one of the reasons that I've been working on element selector, which will let you just enter a URL and play with that from a command line, which might be kind of similar to what you're talking about.
Thank you.
Should we, what versions of Angular have you tested with this? Like, should we be careful with what version we use, or?
Yes, there is some requirement. I believe 106 and higher.
All right.
It will work with.
All right, thanks.
Could you say something about how it integrates with Angular Fire?
I'm not familiar with that, so no.
Angular Fire is just a backend for Angular, and it should work just like it does with any other Angular app.
Yeah, it's backend agnostic, completely.
Question, comment. Okay. So I have a comment. It would be cool if, like, before a test and after a test, we could put in markers so that you could tell us what bindings have changed between the two, and then we could go and figure out, like, given a list of those bindings, what is actually test against them.
That would be really cool. There's also there's a lot of sort of related ideas that I want to work with. Once 1.0 is out, like you could get lots of information about performance automatically from end-to-end tests. You could get information about you're doing something that's really inaccessible in your application. So there's a lot of additional metrics that could be included with this that I'm excited to explore.
All right, everyone, thanks for your questions. Thanks for coming tonight, and we'll see you next month.